Hello friends, today I will discuss about use of directional and non-directional earth fault protection in case of feeder. So before going through this video, first I will discuss how does relay sense the earth fault in a feeder. So here the feeder is connected from a substation. A substation is connected with a source. Now, so power is flowing from this substation to this feeder. This is the red phase, yellow phase and blue phase of the feeder, and CT from the CT secondary, that is from the CT secondary red, yellow, blue, the current input is taken to the relay. Here 1 and 2 is red phase coil for relay, and 3 and 4 yellow phase coil for relay, and 5 and 6 for blue phase coil for relay, and 7 8 for neutral coil of relay. So here current is flowing from P1 and P1 to P2, that is load is flowing from substation to the feeder end, and therefore in the secondary side the current is flowing from S2 to S1 direction. So S1 terminal for red, yellow and blue phase is connected for relay coil, red, yellow, blue phase for terminal 1, 3, 5 respectively, and 2, 4, 6 terminals are sorted together to form the neutral, and 7 is connected to the input of the neutral coil, and 8 is taken back to the all the S2 terminal and sorted together, so that the current, any unbalanced current or fault current, can back to the S2 of all phases. This is how the relay connection is made, and and this neutral coil of the relay sends the earth fault. So under balance condition, the neutral coil current is sum of the three phases current, that is IR plus IY plus IB. Under balance condition, IN is equal to 0. So there is no residual current during balance condition. If any unbalance occur, then there will be a small portion of residual current. It can be treated as earth fault, but the relay set must be beyond this sense current, so that earth fault can be sensed by the relay. Now for non-directional relay, the relay does not see the direction of the fault. It only senses the fault by means of the earth fault current, sensing the magnitude of the current, that is IN must be greater than of the set value, that is I set, magnitude of the I set. For example, if I set is 0.2 ampere, if this relay neutral coil sends 0.2 ampere greater than of 0.2 ampere current, then it will send a trip signal and trip the circuit breaker to clear the fault. Again, if earth fault occur in the red phase and fault current is 2000 ampere, if the CT ratio is 400 by 1, then in the red phase secondary current value of the current is 5 ampere, and if the load current is 200 ampere, and value of the secondary current for Y phase and blue phase is 0.5 ampere respectively. So what is the value of the neutral coil of the relay sense during the earth fault condition? So IN is sum of these three current, that is IN is equal to IR is 5 at an angle 0 degree, plus IY, that is 0.5 at an angle minus 120 degree, plus IB, that is 0.5 at an angle 120 degree. So IN is equal to 4.5. So this relay coil sends 4.5 ampere current, since set is 0.2 ampere. This relay send a trip signal to clear the fault. Now why to use non-directional earth fault relay? Here example has been shown to use of non-directional earth fault relay. Here a source is connected with this 33 kV bus, and between 33 by 11 kV there exists a transformer of delta star type where star point is grounded, and from this 11 kV bus to feeder is connected, that is feeder A and feeder B. So in the feeder there exists CT, that is red, yellow, blue, and the secondary is CT secondary is connected to the earth fault coil or neutral coil of the relay. Similarly for feeder B, and similarly for this LV side of the transformer, since the star point is grounded, if any earth fault occur in the downstream side, then this star point grounded path will provide the return path of the earth fault current. So this LV side CT sends this earth fault current also, but in HV side is delta connected, so there will be no effect of the earth fault in the HV side. So for example, in the feeder A earth fault occur, then this earth fault current will be supplied from the LV side of the transformer from the 11 kV bus to the feeder to the earth fault point. Since in the feeder B there is no source, so no current will be feed from this feeder B. Only load current will continue to flow to the feeder B. Since the non-directional current sense the magnitude of the earth fault, therefore the CT secondary is connected to the relay will sense this earth fault as the sum of the three phase current, as this current is earth fault current, set current is greater than the relay setting, so this relay send a trip signal to clear the earth fault. Again, this due to this earth fault, this LV side earth fault shall not operate, and that is why the relay coordination should be such that if this relay failed to clear the earth fault, then only the LV side relay shall clear the earth fault with time delay. So this is the example where the non-directional earth fault relay can be used. Now an example has been shown where to use the directional earth fault relay. So in this example there exist three substations: substation A, substation B, and substation C. In between each substation there exists one line, that is in between substation A, B one line exists, in between A to C one line exists, and between B to C one line exists, and a source is connected only with substation A. Therefore under normal condition power will be flow from substation A to B, substation A to C, and from either from B to C or C to A via substation A. So the earth fault relay is connected for each section of the line. Here earth fault relay is connected, here also connected for line section AB, and line section BC earth fault relay is connected for substation B end and C end, and again for substation AC for line section AC earth fault relay is connected at substation A end and substation C end. Now if fault occur at this point, due to fault occur at this point, this fault will be feed from substation A end and also from substation B end via line AC and CB. So due to fault at this point, the current sensed by this relay and this relay will be same, as this current is feed from substation C end, and the magnitude of this relay current and this relay current is also same. So if non-directional relay is used, then due to fault at section AB at this point, this relay send this fault, and also this relay will sense this fault, and also this relay will sense this fault. So under fault condition, this and these two relays sense this fault and clear this circuit breaker to clear the fault. But due to use of non-directional relay and due to fault at this point, this relay and this relay also sense this fault and this circuit breaker will be tripped under fault condition. So this is the maltripping of this section. So here the non-directional relay cannot be used. Here to remove the earth fault relay, the directional earth fault relay is used. Now how does the directional earth fault relay sense the direction of the fault? Now the direction of the current shall be in the forward direction. Here forward direction means towards the line direction. Towards the line direction means the current is flowing from P1 to P2 direction. So the fault is occur at this point, therefore from substation A end the current is flowing from P1 to P2 direction, and again from substation B end current is flowing from P1 to P2 direction. P1 is the bus side, P2 is line side. Again for substation C end current is flowing from P1 to P2 direction. Fault at this point, the current is flowing from P1 to P2 direction for at this relay. So this relay and this relay shall operate for use of directional earth fault if only the direction of the current, sensing the direction of the current. But again there is only one more parameter, that is the use of residual voltage, that is under fault condition, that is fault occur is very close to this substation C, then if fault occur at red phase, then red phase voltage will be 0. So the residual voltage, that is residual voltage is connected from the PT secondary in open delta fashion. So the open delta voltage will be sum of this three phase voltage, that is BR plus BY plus B. Here the red phase voltage is 0, then VY plus BB will be sum of this two voltage, and therefore this relay will actuate based on the voltage dip and residual voltage formation. But in case of this relay, as fault point is far from this substation, this voltage dip will not be that much as compared to voltage dip at this substation A. So this relay will sense the direction of the current, but as the voltage dip is not that amount, this relay will not trip. So due to use of directional earth fault relay, only this two relay will clear the fault and clear the fault. So friends, this is how the directional earth fault relay is used, where the ringmain lines are used. That is, the different substations are connected in mesh system. So friends, if you like my video, then do subscribe my channel. Thank you for watching.